Welcome back all. So today we're gonna go ahead and play around between we're gonna go ahead and play around between two structures. So the question now that I'm going to pose, it's gonna have a bit of a technical feel to it. So it goes as follows. Can all instances of a structure have a joint attribute? The answer to this question is yes. The attribute is called a static attribute and is shared with all the variables of that structure. Now, if you did not understand what I just said, or if you would like to replay it, something like that, feel free. But a far easier thing is to have a look at the example, because I have created these neat little definitions for each one of these segments, written them out, etc. But then as I was writing out the definitions and the explanations for all of this, along the merry way, I just realized the same thing that was a problem for me would probably be a problem for a lot of other people. Dry talk means little. So let's get into code and let's see how this actually looks like. Anyway, we're gonna go ahead and create another structure. So it's gonna be struct book, and we shall play around with it. You see, CodeBlocks is kind enough to give the semicolon at the end. And now we will include some different things. So ID, this will be the ID of the book. And the next one that we shall include will be the name of the book. Now name, that would be a string. So we will go ahead and include string. Thank you very much. And now we shall do std : string name. There we go. And we shall also want the author of the book. Okay, so yet another string, right? String author. Awesome. And now we would like to have a publication date of this book. I guess we could create 3 ints here, right? Well, we could, but have a look at this. Date, published, semicolon at the end, and down below we will have a book count. So, I don't know, static int count. Okay, so in the structure book, we can note the 2 interesting facts. The attribute published is of type date, which is a structure. Here it is. We've created it. Which means that structures can have their own structures as their attributes. So once again, structures can have other structures. So structure book has another structure called date as an attribute. So look, it's an attribute here. That's one thing. And the other thing to note here is that the attribute count is static. So this is a static attribute. What does that mean? Basically, it means that all variables of type book will share the attribute count. So all the variables of type book will share this attribute so that it doesn't get mixed up. You will see soon enough what I mean by this if you didn't figure it out already, and I trust that you did. So, shall we let's go ahead and remove this. And let's go ahead and type in, okay, one tab. As before, we will create the variables, so of type book. So B1, B2, and it's going to be like B1.id. ID we shall initialize to 0. B1.name. Okay, so the name will be, what shall the name be? Anybody have any bright ideas for the name of the book? I don't know. I want to invent a completely random name. Okay, so random name. I sincerely hope that there isn't a book out there with the name random name. If there is, this has no connection to it whatsoever. Okay, so let's go ahead and type in b1 dot author. This shall be equal to who shall be the author of this book. Okay, so the author of this book will be a random guy, let's say. I don't know, someone. Okay, so the name of the book is Random Name, and the name of the author is Random Guy. I know I am creative beyond belief, but hey, what can you really do about it? And now we will have a count, which is static and is shared across all the variables of type book. So it is shared in between b1, which is a variable of type book, and it is shared by b2, which is also a variable of type book. b1 dot count equals 1. Okay, so now let's print out the count of book 2, right? Why? Because we have initialized it to 1 here. You see, count has been initialized to 1, but it has been initialized to 1 for b1. Let's see what happens when we print out the value for b2. If anybody wants to take any wild guesses, feel free. I'm sure you can make a conclusion in a rather easy manner. So b2 count, you see, we haven't initialized it for b2 at all, anywhere. This is just for b1. So b2 dot count std colon colon ndl. Okay, let's just go ahead and run it and see what happens. Okay. Seem to have a problem. Undefined reference to book count. That seems to be the problem. B1 book. Okay, there is a comma here. There is a semicolon, which I'm notorious for forgetting. Maybe I'm misspelling it. No way. No way am I that stupid. Okay. Okay, let me just copy paste it. Maybe I am. Maybe I am. There's always a chance. Okay, well, let's try it one more time. Undefined reference to book count. The first one is at line 28 and the second one is at line 30. Why is it an undefined reference? Have I not defined it here? It is defined, like right there, and it's struct book. Let's go ahead and see what the problem could be. Okay, so again on line 30 and here. Why do you suppose it's an unidentified? Let's go ahead and try it like this. Maybe I am that stupid. Book 2. Okay, not book 2, but BO2. It's still an undefined reference. No way, it doesn't matter if it's in the same line or not. Well, let me go ahead and check what the problem is. Probably something absurdly stupid, but it's just not occurring to me at the moment. Okay, so I completely forgot about this. I said it like a couple of moments ago, and then I forgot about it. Didn't see it in my notes here, didn't even have it. Anyway, since this is static, you will need to allocate some space for it. You will need to give it some memory space, in a way. So this is what we shall do in order to reserve some memory for it and put it in here. Look, if I, for example, if I do this, and if I try to compile, it's not going to work, okay. But if I just remove static and I do this, it will compile without any problems, although it's going to give me some random value here. However, this is actually, you know what? Just take a look at it one more time. We are printing b2.count. We have not initialized it for b2, and if we run and compile it, if we build and run it, we're going to get some completely random value. Keep in mind, look, this is a completely random value here, but we have initialized B1 count. We have initialized count for B1, but not for B2. And if it's not static, you see, it's not really shared between the two. However, if I make it static, I just need to reserve some memory space for it. And then I will do a build and run again. And you see, now it's 1. Now the value is shared between all the... Okay. Clipping. Okay, so they didn't do a terrible job, but still, I mean, come on. Anyway, the value of the variables is shared. So you have 1, and it's for B2. It's 1 for B2 as well. So the count is shared between the two, between B1 and between B2. Anyway, just don't forget about line 22 here in my code, where we're basically just reserving some space for it because it's static, so we have to do it that way. Anyway, the declaration, the usage, you cannot, for example, this shouldn't actually work in C because of the static declaration here. So you wouldn't be able to use a static variable within a structure in C. However, you would be able to use it in C++. And this is a C++ program, of course. I'm pretty sure about that, but don't hold my word to it. Check it out for yourselves. Everything that I say at all times, and I do believe this is the best approach even to college lectures and to pretty much any sort of lectures of whatsoever, take everything with a grain of salt and don't take anything at face value. Just go ahead and check it out for yourselves. See if it is really so, or if it is something else, or if you can draw your own conclusions about it. Anyway, here we can basically just go ahead and do this as well. What shall we do? Let's go ahead and type in b2.count, and let's go ahead and change the value. So let's change it to, I don't know, 10. And now we're gonna be lazy and copy this. Okay. And this shall be B1. So look, we have changed the value with B2, and it's going to be changed for B1 as well. Look at it. Yep, so it's 1 and 10. And you can basically change it any way you want. So we see that we can have shared attributes for all variables. Since these attributes are not dependent on a variable, we can access them by stating the name of the structure followed by the scope operator. So we can just with the scope operator, like here. You see, we have it here, and that's what we basically did here. And you can do it here in the code as well. If you just type in book : count equals 100. So you see, you can. This is also possible without any problems. And now you can use either one of these two. We can be lazy again and use this. So let's go ahead and create a printout. So you see 1, 10, 100. No problems. They're all printed out there. We don't even need a variable to access an attribute like this if the attribute is static. Anyway, I would like to apologize for this small error that I made here. I completely forgot about that. That we do need, the memory space is required, and that we do need to do this. But as I said, there are some differences between C and C++ in this regard that my mind just wandered off in a completely wrong direction. Anyway, I bid you all farewell and hope to see you in the follow-up tutorial, where we shall deal with arrays that are made of structs. So I hope that I've formatted that right. We shall deal with arrays of structs, let's put it like that. And we'll see how that actually works out.